All right, this is Tech Math 3 Pre-Calculus Combined class. We're in section 12-3, which has to do with doing trigonometric graphing of everything that we haven't trigonometrically graphed yet. What? Yeah. So we should have a review. Y is equal to A sine X. Well, this is really bad. Where's my big eraser? There, that's better. A equals A. Y. That's better. Equals A sine X. What's the amplitude?
A.
Absolute value of A, in case it's negative. What's the period?
2 pi over B.
2 pi over B, and B is how much? 1. All right. So Y is equal to A sine BX plus C. What's the amplitude? Absolute value of A. What's the period? 2 pi over B. Now I need the littler eraser.
Is that an X or B? BX plus C? Sure.
Keep up there, Raimundo.
It's cursive. What is it?
It's an X, obviously. What's this over here? I don't know what that is over there. That's a horse of a different color over here, I think. Is that better? What is the phase shift? C over B. Right? So we're going to do it one more time. Y is equal to A cosine BX plus C plus D. All right, what's the amplitude? A. What's the period? 2 pi over B. When are you going to forget this next? Tomorrow. Typical. And what's phase shift? What's the displacement? All right. So that covers just about everything. All right. That's review from Monday, because I know you forgot it already. All right, so now the issue is we want to do a tangent function. Okay, so y is equal to tangent x. We remember our thing where we had 0 and 30 and 60 and 45 degrees and 90 degrees. And we remember that the tangent function was 0 there, infinite here, 1 there, the square root of 3 here. What was this one? Square root of 3 over 2 or something. I forget. I forget what that one was. Anyway, it'll come to me. No, not 3 over 2. So the sign is a half. So it's a half over the square root of 3 over 2. So that'd be the square root of 3 over 3.
That's exactly what I said.
Yeah, all right. So now we're going to go and graph it. This is pi over 2, right? Yeah, there we go. Now we got it all squared away here. Okay, so I go through 0 at 90 degrees and at minus 90 degrees. I'm going to be infinite. So I draw a construction line. So I know I'm not supposed to go across my construction line. And then I come down, I go through there, I go like that. And at 40, that looks like 45 degrees. At 45 degrees, I'm at 1. Huh? So that's what I do. And it happens again. So it does it again, it does it again, it does it again, does it again over here. And so it keeps repeating itself. Where's it going to pass through 0 there? 180. What is it going to pass through 0 there? 360. I can do it in pi. I could say that this is pi over 2, and this is minus pi over 2. You know, I could do that, and this is pi, and this is at 2 pi. So I could do that too if I wanted to. Okay, well, that being the case, what happens if y was equal to the cotangent of x? Well, that means if the tangent of x is 0, and then the square root of 3 over 3, and then 1, and then the square root of 3, and then infinity, cotangent would be 1 over that. So I'd be infinity at 90, and I would be 1 over that, so it'd be square root of 3. What's 1 over 1? Yeah, that's what I thought. And then square root of 3 over 3 there, and 0 here. So my cotangent, I would come out to 90 degrees, and then I'd come over here to 180 degrees. I'd throw in a construction line, and then I'd come down from infinity, pass through there, do it over here. And then, again, that would happen multiple times. Oh, that was really good. That was just so wonderful the way I drew that one. Yeah. So if this is at 90, then that guy's going to go through at minus 90. And this guy over here is going to go through at 270. And if we wanted to, we could write it down as minus pi over 2 pi over 2 pi 3 pi over 2. So we could do those things if we wanted to do it in radians. And no one really cares to do it in radians. All right, so that's what I would do if I had that situation. Now, my situation is I got y is equal to the secant of x. So what am I going to do now? Well, I remember that secant of x is the same as 1 over what? Cosine. So what I'm going to do is I'm going to construct a cosine curve. Down, up, down, up, down, up. Just like that. And then I'm going to say, well, when the cosine curve goes through 0, I'm going to be undefined. So I'm going to put a construction line through each of the spots where I go through 0. All of them. So now I got them. And of course, I'd use my crayons that I got from my little brother, and I'd do a better job than this. And then I'd say, well, that being the case, when I'm positive, my curve's going to look like this, and it's going to look like that, and it's going to look like this. Oh, that was really good. And then on the negative side, when I'm negative, it's going to look like that. I'm going to be, the word that you're looking for is asymptonic. So I'm acetonic to the, they're isotopes. Yeah, they're isotopes, so they're acetonic to the, yeah, it's spelled with 2 S's probably. And so that's how I would do my secant x curve. I'd draw a cosine curve, and then I would add the secant on top of it. Well, how do you think I'd do a cosecant curve? Y is equal to the cosecant of x. What would I do then? You know, I'd ask my little brother to do it for me. Well, I'd remember that that's 1 over sine x. So I would start with a sine curve. So I start with a sine curve, and I just draw it just so wonderfully, right? And that goes out to 2 pi there. Goes up to 1, goes down to minus 1, if anybody cares. And then whenever I pass through 0, I'm going to be going to infinity, so I would go and throw in construction lines when I go through 0. What's another word for going through 0? Anybody know? No, it's not Chris's grade.
Yeah, mine.
As much as is much higher than that. Okay, they're called nodes. So the
Sure, I just didn't want to be around once right here.
yeah, that'd be good. Yeah, you knew it had to do with Chris's grade. All right, so when I'm positive, I'm going to be positive. When I'm negative, I'm going to be negative, and so that's what I'm going to do. So whenever I do a cosecant or a secant curve, I draw the corresponding sine curve or cosine curve first, and then put it on top of it. Okay, good enough? Yeah, well, it might be good enough. All right, so now we're going to try to do a problem, a real problem, instead of these made-up things. So you get to do number 1, so I get to do number 2. Y is equal to tangent 4x. Okay, so what is the amplitude? Well, on a tangent curve, it doesn't make any sense to have an amplitude, so we don't really consider it. But okay, it's got a 1, but it's a big deal. We're not going to do anything about it. What's the period? The period is pi over 4. Now, why is it pi over 4? When we come back here, this is a cosecant thing, and it's 2 pi, right? 2 pi is the period to get a full cycle. But if I look at the tangent curve, where's my tangent? If I look at the tangent curve, which I can't do because it's way over here someplace, it repeats itself after 1 pi, and then it does it again. So its period would be 1 pi, so that's why we only have pi over b. If it was bx for the period of a tangent curve. All right, so it's going to be, that's what it's going to be. Okay, so we got it. We draw our xy plane. Are we going to draw it any different than we drew the last one? No, so we're just going to put tick marks down here and like that, and then we're going to go in. We're going to come up. We have to go through 0. We're going to go over. Come up, go through 0, come over. That was really bad. Come up, go through 0, whatever. And then we're going to say, well, if the period's pi over 4, then this had better be pi over 8, and this had better be minus pi over 8.
Is that because it's 2 cycles on 1 or what?
That's right, exactly. So that means half of it's this way, half of it's that way. And then this would be 3 pi over 8, because that's 1/4 more. And this would be 5 pi over 8. And at pi over 16 right there, that's going to be 1. Okay, well that's 1 too much mark. Okay, so that last guy you don't have to do. And I'm not sure I did it very well either, so we'll try it again. Pi over 16. But that'd be the 40. Pi over 16 times 4 is what? Pi over 4. Pi over 4 is 45. 45 is 1. So tangent of 45 is 1. So that's why that has to be 1. Okay, so, but there's no difference, until I put what the x-axis is, there's no difference in my curve, whether it was tangent 8x or tangent 5,000 million x or tangent 3/4 x. It's the same curve every time, and then I put axes down saying what it, to protect the innocent. All right, well that's number 4. Oh, number 4. Y is equal to minus tangent 3 over 2x. All right, so now I've got this minus sign sitting there, so everything that's positive is now negative. It's going to invert, right? I've got a period that's going to be pi divided by 3/2, also known as 2/3 pi. Yeah, pi divided by, yeah, 2/3 pi. Okay, so I know my period, And I know I have to draw it the other way. Okay, so I'm going to go do that. I'm still going to pass through 0, but the other guy, I'll put some marks out here so I'm protecting the innocent here. Okay, those are the places I'm going to pass through infinity. Well, I'm not going to do that. I'm going to pass through infinity. Yeah, I guess.
On every thick.
Well, no, I don't think so. I think they're too close together. Yeah, that's better.
One thick off the thick.
It's hard to say. Okay, well, anyway, because of the negative sign, I got to be positive when I was negative and negative when I was positive. So I'm positive when I'm negative, negative when I'm positive. Well, that was really wonderful, wasn't it? All right, well, if this is 2/3 pi from there to there, then this guy's got to be pi over 3, and this guy's at minus pi over 3. And to mark anything else would just make it look like I was overachieving, right? And this guy's over here at pi, because I need 2/3 pi to get from there to there, and this guy over here would be minus pi. So those would be overachieving things. Just 2 of them would be perfectly okay. But the tangent curve got inverted because I have a minus sign, and my period's a little different than what it was. Okay, number 6.
Number
6. Y is equal to 2 cotangent 1/3 x. So I've got an amplitude sitting here that looks sort of like 2. So I'll have to deal with that at the end of my drawing. And I've got a period that is pi over 1/3, also known as 3 pi. And I would pick up my pen at the proper time, it'd work better, right? All right, so 3 pi is going to be my period. Okay, so that being the case, I ignore everything else and I just draw a normal cotangent curve. So I'm going to put a construction line, construction line, construction line, one over here too. All right, now oh, that was pretty bad, one here. Now I have too many. Oh, well, it doesn't matter. All right, so the cotangent is negative where? It's negative, it's positive over here, right? Okay, goes like that, passes through that, boom. All right, that's better. Goes here, passes through there, like that. Starts high, passes through there. Okay, so wow, that was really in scale. All right, now we said it's 3 pi between there and there. So I've got 3 pi is my between there and there. So that means that this had better be 3 pi over 2, and this is going to be minus 3 pi over 2, and this is going to be 3 pi more than that. So that would be 9 pi over 2. 9 pi over 2. Because 3 pi would be 6 pi over 2 plus 3 pi over 2. 9 pi. All right, now the issue is, what are we going to do with this, this 2 sitting here? What are we going to do with it? How are we going to recognize that that 2 is there? Well, the 45-degree mark is that spot there. And that's going to be 3 pi over 4. Okay, I'll try it again. 3 pi over 4. So at 3 pi over 4, we expect it to be at 2, not at 1. And so that's how I would handle the amplitude being 2. If I could actually draw a 4 on the board. I think what I need to do is invest in a bigger tablet. What do you think? Think I should get a bigger one that'd help out? Wow, that's way too big up there. Yeah, that'd be pretty bad. Okay, so looks like number 8's next. I have y is equal to 4 cosecant x. So we're going to go with an amplitude of 4, and we're going to go with a period of 2 pi, and we're going to recognize that the cosecant is 1 over sine. Okay, so those are the things that we remember. Now that we remember it, we will go and do something about it. So we're going to draw a sine wave. Up, down, up, down. Oh, that's just perfect. Up, down, down. Okay. When the sine function passes through 0, I go to infinity. So there's something funny that happens at each of those places. So I'll put construction lines in. And clearly I made it so I had too many nodes, so I have too many construction lines. There's a word for that. I forget what it is, but probably derogatory. Probably applies. All right. So when I'm positive, I'm going to be going up. Where's my thing there? Okay. So positive, I'm going up. I don't touch my construction lines, or I pretend like I'm not touching them, one or the other. And oh, that was good. I just want to be there. Okay, so what is this point right here that goes across right there? As Raimundo said, that is the 4, which is our amplitude, and minus 4. So the 4 is still there. It's not a 1/4 because it's not 1 over 4 cosecant x. It's 4 times 1 over sine. So that would be a 4, not a 1/4. Well, isn't that just special? I wonder if do I have a curvy line here that I could use? I wonder. I probably do. What was that, 8? That was cosecant. So we need to do a secant one. Secant one. Number 14. That'd be a good secant one. Number 14. Y minus 5 secant 3 over 2x. Okay, so we write down the things we know. The amplitude is 5, but there's a negative sign there, which means all the stuff that was on top is now on the bottom. So we'll have to deal with that later. Our period is 2 pi divided by 3 over 2. So we're going to multiply top and bottom by 2 over 3. 2 over 3. Those guys go away. And we have 4 pi over 3 is our period. Okay, and we have a secant, which is 1 over cosine. Okay, so what we're going to do is we're going to draw the cosine curve. Oh, that is just really bad. All right, that's plenty. And where the cosine curve passes through 0, we'll throw in construction lines. Yeah, it seems like I should be able to do better on my construction lines. Yeah, why don't we just start all over here. Be better just to erase it, right? All right, that's better. We'll start all over again and not make as many. All right, so we're going to go down, up. Oh, that's much better. Down, up. All right. Now I don't have to have as many construction lines. All right, so I'm here, I'm there, I'm here, I'm there, and I'm there. Now, my amplitude's 5, right? Okay, so where I cross here is 5, and when I'm down there, I'm at minus 5. Okay? But I have a negative sign, so that means I would have been positive like that, but I'm really negative like this. I would have been negative like that, but now I'm going to be positive like this. I was going to be positive, but now I'm going to be negative. Okay, I'm negative, so that means I'm going to be positive. I'm positive, that means I'm going to be negative. Okay, so I'm going to use the minus sign to have myself remember that I'm going to have it be a mirror image. Okay, how far do we go in the problem set anyway? We only go to 11? Excellent, so I don't have to do number 20. Okay, moving on to section 13. Oh, wonderful. Just what I wanted to know. Yeah. Last night, I had a problem. There's a well, a voltage well, a negative voltage down to there, and there's a wave going this way. And the equation, the wave formula on this side is A e to the I k x plus B e to the minus I kx. And the equation inside the well is C cosine Lx plus D sine Lx. And the equation on this side of the well is F e to the I kx. And the issue was that and 0 is right there, and right here's minus A, and over here's A. So the issue is at the point x is equal to minus A, these two equations have to be equal. And at the point x is equal to A, these two equations have to be equal.
So that's vectors?
Okay? And the thing was to solve for A, B, C, and D in relationship to F. So that's what I had to do. 7 pieces of paper later, another 4 pieces of paper wadded up and thrown away. I had the problem solved, only because I had the solution in front of me. But in so doing, I had to take things, I had 2 cosine x sine x. Anybody know what 2 cosine x sine x is? Well, on the back of your cover of your book, it says 2 cosine x sine x is sine 2x. Sine 2x. And then I had other things that said cosine squared x minus sine squared x. And you look in the back of your book and you find that that's cosine squared x. So I was actually using the trig identities out of my Tech Math book. My Tech Math book, of course, was sitting in my office at Iowa Western, and I was at home sitting in front of my television watching NCIS at the time, which probably, well, that's probably why I was wadding up paper and throwing it away, but that's beside the point. So those relationships showed up in the solution of this problem in a way that was not intuitive. Okay, so that's the case. Well, anyway, that's what we're going to do in chapter 13, among other things. So on page 446, we find that we have sines. Isn't that lovely? We have cosines. Isn't that lovely? We have tangents, cotangents, cosecants, secants. And we relate those properties to some point on a curve. So I got some point that is xy and some distance r, and I have some angle theta, and that angle theta is y over r. And that angle cosine, the cosine of the angle theta is x over r. And the tangent of the angle theta is y over x. And the secant and the cosecant and the cotangent are one of those things. No, they're all what they are. They're all in your book. There shouldn't be any question at all about what it is. And that's an R on the bottom. And then there's the inverse guys. And then there's things like sine over cosine is going to be tangent. And cosine over sine is going to be cotangent. And isn't that lovely? And if I look at the xy plane, and I got a point P up here at xy. Okay, so I got that. So there's y, and there's x. And I ask you, how big is r? What are you going to say? R is equal to, okay, we'll do it a different way. I got this right triangle, and I've got A, and I got B, and I got C. Okay, what can you tell me about that right triangle? You can tell me that, yeah, C squared is equal to A squared plus B squared, right? Pythagorean Theorem, so that would be the case. And so R squared would have to be x squared plus y squared, right? That would have to be the case, wouldn't it? Yeah. All right, that's good. So I got this thingy here, and I'm going to go and put a unit circle on it. Okay, so here's there we go, unit circle. Now, the thing about a unit circle is, what's the radius of a unit circle? R is equal to 1. That's why it's called a unit circle, right? Oh, yeah. All right, so, and here's my point X and my point Y. Okay, so there's my point X and point Y. Down here is my point X. And over here is my point Y. Okay. What's the sign again? The sign is what? The sign of theta is y, yeah. Because r is 1, why would I want to write it down? I got a unit circle. And what's the cosine of theta? It's going to be x. Okay, and r squared is equal to x squared plus y squared. So 1 must be equal to sine squared plus cosine squared. Everything was fine, and then Raimundo broke my train of thought, and I messed up the last thing there. We'll try better now. Okay, sine plus cosine squared theta. Is that better? And we'll make that a little bit better. So now does it matter whether I have a unit circle or whether or not my circle is bigger than that? Like out to there? When I go and come out here and I take the sine and cosine of my new point, 0.1, might be 0.1, might not be, 0.1, x1, y1, got some new point sitting out there. Okay, same angle theta. If I take the sine of the angle that associated with that particular vector and the cosine, am I still going to square them and I'm going to add them together? Am I still going to get 1? I better. They're still the same numbers, right? Yeah. So that's what's on the top of page 448. Sine squared plus cosine squared is 1. And then that's something you take in your mind and you tattoo it to the back of your mind. There's anything left there to tattoo to, and you remember it forever because you're going to use it forever. And then you say, well, that could be something else. If I divided all this by sine squared, then I could have a 1, plus I could have a cotangent squared theta is equal to secant squared theta. So I divided everything by sine squared. This would be cosecant. Cosecant. Yeah, if you're ever in the second year electronics lab with Dustin, not our Dustin, but the other Dustin, and he's laughing really loud, he's normally laughing at the videos I made for Tech Math 4. Because I'll go back and he'll see a mistake, and I'll go 4 or 5 lines, and I'll go back and erase the whole thing and redo it. He'll be there laughing at the situation, because it is pretty hilarious. Now, if I divide everything by cosine squared, I would get tangent squared theta plus 1 is equal to secant squared theta. So I don't remember this guy. I don't remember that guy. All I remember is this guy. I always remember him. But if I see something that looks like those guys, then I go back and ask myself, is it? You know, is it really trying to tell me something different? But I derive those guys. These are things I don't have memorized. These are something that I derive. Okay, well, with that, the only thing left to do is problems. So number 2, we're supposed to prove that the 1 over tangent is the same as cotangent. Now that would seem like a pretty silly thing to do, right? Except in 1956. What happened in 1956? Yeah, exactly. You weren't born then. I think it was 56. The Soviets put a satellite in orbit that made noise.
Yeah.
Sputnik, making us look bad, and then we had to redo all our math, and we had to do formulas and proofs and things like that on our math. And that's not the whole story, though. Anybody know the whole story about Sputnik going up? Yeah. Enrique was alive then, right there in 56? Oh, no, he says he wasn't. But his mom and dad were born already. So, yeah. So, we have things today. We have a unified military service. We have Army, Navy, Marine Corps, and Air, do we have Air Force? Something like that. Anyway, we have those guys. But in 1956, our military was very fragmented. So the Navy would never think of talking to the Air Force, or the Air Force talking to anybody else. They all had the same boss, but it was very fragmented. Anyway, so the Navy is sitting with a rocket sitting on a launching pad, ready to take off, with a satellite on board, with a radio transmitter in it, ready to take off 1 week prior to Sputnik taking off. The Army has a rocket sitting there with a satellite on it that doesn't have a transmitter on it. It's ready to take off 1 week before Sputnik. The Air Force is sitting there with a rocket with nothing on top yet, but they're thinking about putting something on top that would be a radio. Okay, that's the air farce that's sitting there. Anyway, due to political reasons, someone decided that the Air Force would be the first service to put a satellite in orbit that made noise. Okay, so 1 week before Sputnik, the Navy guys are told, turn off your stupid transmitters. We don't want that. Okay, we'll turn them off. Okay, so they fire their rocket 1 week before, and their transmitters are off, and everybody's fine because the Air Force is going to do it first. And then the good old Soviet Union fires up Sputnik, and we lost the race. You know, they got there first. Yeah, just because of infighting politics among the services at the time. Now, all things being equal to the Air Force, given another 2 weeks, they would have been there too. It wasn't like we weren't getting close. I mean, you figure that we still went and spent billions and billions of dollars on a race with the Soviets that we would have won if we just let the Navy fire off their stupid missile in there and put a satellite in orbit. Okay, but this is 56, so that means we don't have any water-launched ballistic missiles yet from submarines. We don't even have submarines designed that could do that. That's a very long time ago. And I was 6 years old then, but it changed the math we were taught. So what we're going to do with trig today out of the Tech Math book is exactly what we did because of Sputnik. And so anyway, back to what we're doing. So the issue is, how do I show, when I know the tangent of theta is 1 over cotangent, what am I going to do to show that? And so what I would do, what I'm going to do is change one side of the equation and not the other until the other side of the equation makes it correct. So I'm going to change the tangent to be 1 over sine divided by cosine. And then I'm going to multiply both sides by cosine over sine, cosine over sine, and then I'm going to cross out those cosines and these sines, and then I'm going to write down cosine theta over sine theta is equal to cotangent theta. Done, check. All right, well, that's pretty silly. That was bordered on silliness because we already knew that 1 over tangent was cotangent. Why didn't we just put a check over here? Check. Wouldn't that have been much more better? But we're in section 13.1, and in 13.1, we're supposed to take our trig functions, change one side of the equation to just sines and cosines, manipulate it until we get the other side of the equation. That's what we're supposed to do. All right, what was that? Well, that was number 2. All right, that was number 2. So now, how many out there have children? Okay, how many have children in high school? Yeah, all right. So remember this when you have children in high school. Exactly what math do you want them to take in high school? We have 2 choices. What you did, right? Or something else. Okay, so how many people with their kids in high school want them to take the same math that you did? Show of hands. No way. Exactly. So you want them to be done with Calculus 1, Calculus 2, prior to graduating from high school, with college credit already, right?
Yeah.
Would that not have been wonderful? If you did that in high school, would that not have been okay? All right. My third daughter did that. That's what she did. Then she went to the Coast Guard Academy, and they didn't transfer any of the credit in, but she started in Calculus 2. She never took Calculus 1 at the Coast Guard Academy. She never had credit for it. Anyway, so now I got my first, that's a third child. Okay. So the first child, you sort of, how do you make the first child right? You can't. Whatever the first child does, you correct things for the second or the third, but there's not a damn thing you can do. How many first childs do we have in the room? Okay, all right. So that's true, right?
I'm the first.
Yeah, you're the first. You could do. I'm a first child too. I could do nothing wrong. Whatever I do was perfect. And my mother got my report cards from high school and put them on the table over the summer. And my sisters looked at them and said, "Gee, I thought he got all A's. He's not very smart. He got B's." Oh, I never told you that I didn't. Yeah, it must have been. Anyway, back to the issue. So this is a first child. When do you take Algebra 1? 7th grade, 8th grade, 9th grade, 10th grade? So normally you do it in 9th grade. So if you take Algebra 1 in 9th grade, then you do geometry in 10th, and then you do Algebra 2, and then you do a pre-calculus type thing as a senior, right? Well, if you do that, you didn't make it to Calculus 1, right? So nowadays what we do is we do in 9th and 8th grade, we push Algebra 1, so we can take geometry in 9th grade and Algebra 2 in 10th grade and a pre-calculus guy in 11th grade. So we can do a calculus type class, and we'll do and it won't be a very good calculus class in high school, but we'll do one in high school. All right, so that would be, if you're going to be a doctor or a lawyer or something, you should be doing something like that, right? So anyway, my lovely daughter, the oldest one, she's not my daughter until the summer between 8th and 9th grade. Okay, so my oldest daughter is 5 years younger than she is, but now I've got a daughter going into 9th grade, and she's in 9th grade taking Algebra 1. Okay, that seemed like a good idea, and so she did that, and she got an A. You'd expect that, right?
Of course.
And then she's in 10th grade. It's obvious that she needs to double up and take geometry and Algebra 2 in order to get to the calculus thingy, right? Right. So she's in honors geometry, and she's in a regular geometry Algebra 2 class. Okay. Now it's Thanksgiving, the day before Thanksgiving. So here's Thanksgiving. Thanksgiving, right there, Wednesday. And what happens the day before Thanksgiving? Student, parent, teacher meetings at the high school, right? Now, who is her Algebra 2 teacher?
Mr. Brokey.
The basketball coach. Okay. What's her grade in the class? A. How many other A's in the class are there? 0.
Yeah.
Okay, so we walk in. Now, her honors geometry teacher is the head of the math department. Okay. So anyway, we go to the algebra. Now, you go to parent teachers meeting, and your kid's got an A. You're supposed to walk in and say what? Good teacher, giving my child A. Good teacher, and walk out, right? We walk into the meeting. What the heck is our daughter doing in your class? That's how we start the conversation. Probably a little more profanity involved because we were Navy at the time. And he looked at us and said, "You're absolutely right. What is she doing here? I mean, it's terrible. She's killing my curve. She's ruining it for everybody else in the class. We got to get her out of here." And the honors algebra 2 class is at the same period of time that my class is. She can just go in the other class. Perfect. Yeah. All right. So so that's the plan. And they use the same damn book. It's not like she needs another book. Yeah. Okay. So we go to the head of the department, geometry teacher, and we talk to her about, oh, great idea. We ought to do this. Yeah, no problem at all. They're a chapter ahead, chapter 8. So if she did chapter 8 over Thanksgiving break, she'd be caught up, and then she could just be in that class. Oh, good idea, excellent. We go to the, now, how many of your parents met with principals of your high school? In your high school?
Good things or bad?
On a yearly basis.
Oh, not the usual basis.
On a yearly basis, yeah. Well, we are on first name basis with all our principals because we're forcing our kids, because you're a moving family, we're forcing our kids into these things. So anyway, we get to the principal. Oh yeah, great idea. Okay, now we're walking to this teacher who has the honors algebra 2 class, and the bell rings, and everybody leaves. Okay, so we go home. We go home, and
Nice.
anyway, so that's the way you handle children
Yes.
when they get to high school. That's the way they should have handled you while you were in high school.
You got that right.
Yeah, you sure do. Okay, number 6. The tangent of theta times the cotangent of theta, we're supposed to show that that's 1. Well, of course it's 1. One's a reciprocal of the other. All right, well, but we're supposed to change this to sine theta over cosine theta times cosine theta over sine theta, and then take out our red marker and cross out the sines, cross out the cosines. 1 is equal to 1, check. Oh, well. Maybe they'll get harder than that. What do you think? Think they might?
Yeah, just a little bit.
What do you think? You want, what do you want, 10?
46.
46? All right, we'll do 46 next. Yeah, why don't we do 22? That looks, yeah,
Yeah, sure.
22. So what we're doing is we're changing everything to sines and cosines, and then trying to make one side look like the other. Okay, so we have cotangent theta minus cosine theta is supposed to equal cotangent theta 1 minus sine theta. That's what it's supposed to be. Okay. So it doesn't matter which side we keep and which side we manipulate. So we're gonna keep this side, cotangent theta minus cosine theta. Okay, we're gonna keep that sign. We're gonna distribute this cotangent theta minus cotangent theta sine theta. Okay, and then we're going to say, well, that's equal to cotangent theta minus cosine over sine sine. Then we get out our red pen, cross out, and then we write cotangent theta minus cosine theta. Get out the green pen, check, we're done. In general, yeah, you got a question? Yeah, why are we wasting our time on these really simple things? I don't know. All right, 38. Yeah, 38. Cosine tangent plus sine divided by tangent is supposed to equal to 2 cosine. All right, that's we'll put a supposed to marker there. So that's a supposed to marker. All right, well that's that to be the case. Okay, so we're going to change everything to sines and cosines. on the left-hand side and see where we get. So cosine x, tangent is sine x divided by cosine x plus sine x divided by sine x cosine x is supposed to be 2 cosine x. Okay, get out the red marker. He goes away, he goes away, he goes away, he goes away, he goes away. And now I've got 2 divided by 1 over, did I skip enough steps there? Cosine is supposed to be 2 cosine x. Looks really close. So I'm going to multiply both top and bottom by cosine x. Way to go. Why did I put it there before? All right, cosine x over cosine x. These guys go away. I got 2 cosine x on that side is equal to 2 cosine x on the other side. I get out my marker, check. Okay, one more and then we'll go home. That was, what was that one? That's 38. Anybody got one after 38 they like?
59.
You guys have to do 50, 49?
No.
No.
37.
37?
Yep.
Should I do 37 then?
Sure.
Oh. 37. All right, so I've got 1 plus secant divided by cosecant is equal to sine plus tangent. Is supposed to be. All right, well, that seems reasonable. So on this side I got 1 plus 1 over cosine divided by 1 over sine. If I could spell sine, is supposed to be what's on the other side. I'm going to multiply top and bottom by sine get out the red pen. Those sine x's go away, and I have sine x plus sine x cosine x. Now there's no technical reason you have to put in as many lines of code as I'm using, and it's supposed to be whatever it is on the other side. And oh, look at that, isn't that cute? Sine x and sine over cosine is tangent x, and that in fact does equal sine x plus tangent x. So another lucky guess, and it worked out fine. All right, good enough. Quiz on Friday. Yeah, just what you wanted to know. Don't want to know anything else?